Welcome to a new lesson. In this lesson, we'll be discussing properties of systems of linear equations. Let's take a look at a little example. Does this pair of equations represent parallel or intersecting lines? Well, one thing we could do is we can plot both these lines on a grid. The first equation, y is equal to negative 3x minus 5, is this line. And the second equation is the line right here, which is y equals to negative 3x plus 2. So let's take a look at these lines. We know that the negative 5 tells us that it is y-intercept. And they have two different y-intercepts, a 2 and negative 5. While the slopes are identical. That means, since the slopes are identical and the intercepts are different, these two lines will become parallel. Let's take a look at a harder example. We're going to determine the number of solutions for each line system. Now, for a linear system, there are three possibilities for solutions. We could have one solution. We can have no solution, or zero solutions. Or we could have an infinite amount of solutions. This funny sideway 8 represents an infinite sign. And what we're looking for specifically, if we have one solution, then we have one point intersecting. When we have zero solutions, that means lines are parallel and there are no intersecting lines. So one intersection. We have zero solution, we have zero intersections. And we have infinite amount of intersections. That means we have infinite amount of solutions. Intersections. So what are we looking for exactly is that we don't have to find these intersections in properties of systems of linear equations, but we're looking for two specific things: slope and y-intercept. For one intersection or one solution, slopes are different. And y-intercepts are different. For zero intercepts, slopes are the same, while the y-intercepts are different. And for infinite amount of solutions, or an infinite amount of intercepts, the slopes are the same and the y-intercepts are the same. It doesn't mean that the slopes are exactly, for example, 4 and the y is also 4, y-intercept is 4. It only means that both equations share the same intercept and share the same slope. So using this information, let's take a look at A, B, and C and determine if they have one solution, zero solution, or an infinite amount of solution. Before we just decide what this is, we have to find out what the slopes and intercepts are. So what we have to do is we have to change the equation into y is equal to mx plus b form. So the first question, we're going to x from both sides. We get y is equal to negative x minus 2. Now for the second equation, we have negative 2x minus 2y is equal to 4, and we're going to add 2x to both sides. So we're going to have 2y on one side, positive 2x plus 4 on the other, and then we're going to divide by negative 2 to isolate for the y. So y is equal to 2 divided by negative 2 is negative 1x, and 4 divided by negative 2 is negative 2. then recognize that the slope in this case is 1 for both of the lines, and the y-intercept is -2. Since the slopes are identical and the y-intercepts are identical, there are infinite amount of solutions. So infinite solutions for this equation, for these two systems of equations. Now, what about for B? Again, we have to change this question into y-intercept and slope form. So again, subtract 4 from both sides. We get 6y is equal to -4x minus 10. Divide everything by 6. We'll get y is equal to -4 over 6. We're going to reduce, which is -2/3, by dividing 4 and 6 by 2. And -6 divided by 6, again we divide by 2, we get reduction of -5 over 3. Now for the second equation, we'll add 2x to both sides. So on the left hand side we get -y, on the right hand side we get +2x minus 1. We copy, then we divide or multiply everything by -1 to isolate for a positive y. So we get y on the left hand side, and on the right hand side we get -2x, and -1 divided by -1 is +1. Now in this case, notice the slopes, they're different. One is -2 over 3, one is -2, and the y-intercepts are also different. Because both of them are different, therefore we're only going to have one solution. Let's take a look at part C. Again, we need to solve for y. So in this case, we're going to subtract 3x from both sides of the equation. We'll get y is equal to -3x plus 1. Then on the other side of the equation, we have -6x that we're going to add to both sides. So we're going to have positive 6x on one side and 12. Then we'll divide by -2 to isolate for the y. Again, we have to divide by each and every term. So we get the left side, we get y, and 6 divided by -2 is -3x, and 12 divided by -2 is -6. Notice now that the slopes are the same, -3, but the intercepts are different. Therefore, we'll have 0 solutions because these lines are parallel and not touching. 0 solutions. Let's take a look at our last problem. In this example, we'll create a linear system with 0, 1, or infinite solutions. So given the equation, -2x plus y equals 4, write another linear equation that will follow the linear system with exactly one solution, no solutions, or infinite amount of solutions. Before we do anything, let's use this equation and change it into y equals mx plus b form again. So the first thing we should do is add 2x to both sides of the equation, so that we have y on one side and 2x plus 4 on the other. Again, the 2 stands for the slope, so that's the slope, and the 4 is the y-intercept. So recall that for exactly one solution, the slopes have to be equal, the slopes have to be different, and the y-intercept also have to be different. So this means that for part A, we could pick a value of 3x. Now the slopes are different. This one's 3, this one's 2. And the y-intercept have to be different. So any intercept except for 4 will work. Well, let's just choose 5. There you go. Done. So exactly one solution for this one. How about for part B? No it has to be a parallel line. Now, parallel line has slopes that are exactly the same, but the y-intercepts are different. So an equation has to be 2x, and the y-intercept cannot be 4. For example, it could be 5. What about for c? Well, for infinite solution, it has to be the same exact line, y equals 2x plus 4. However, we could double it, we could triple it, we could half it by 2, and it's still going to be the same equation. Well, not really the same equation, but it will be a line, the same line. So in this case, I'm just going to multiply by 2 everything. So we get 2y is equal to 4x plus 8. And this is a line that has infinite amount of solutions when graphed with y equals to x plus 4.